Alright, welcome back. We're going to start our lesson today on secant lines. It's going to be an important lesson for calculus class, so hopefully this one makes sense to you. So first off, a secant line, alright, is any line that connects two dots on a graph. So it kind of cuts through. Alright, so it's secant line to the graph of the function on an interval a to b. So first off, let's talk about that interval. Notice it uses the brackets, meaning that it is a closed interval, meaning that we are including the value at A and the value at B. So we got the colored in circles there. All right, where A is less than B, and this is where some of you didn't quite understand, and I don't think I made it clear a few weeks ago when we started talking about these intervals, is that you always want the smaller number first and the bigger number written second. A is less than B. You never want this order here to be reversed. All right, so that should never have a bigger number listed first. Always from left to right. Smaller number first, bigger number second. All right, so they pass through the points A, comma, F of A. So what does that mean? Well, it means if you go here to A on the x-axis, and then F of A is like its answer. It's almost like this is x1, comma, y1. And then the next point that's listed here, B, F of B, well, B is down here, and you go to plug in the number B, what answer do you get? So again, it's almost like that is an x2, y2, just a second dot on the graph. And I used x1, y1, and x2, y2 to remind you of something called slope, because that's what this is going to be about today. All right, so the first thing we have to do is understand how that interval works. All right, we'll do some examples. All right, so now the average rate of change on f, that's on that blue function, in the interval from a to b is equal to the slope of the secant line, which is given by finding rise over run, and then they've got this formula, f of b minus f of a, which is the same thing as not x2, dingleberry. Same thing as y2 minus y1 and x2 minus x1. That's why I used that in the terminology up at the top there, so you made that connection. And then we call this the difference quotient. And that's going to be our main topic for the week. We're going to start basic today, though. And the rest of the week we're going to be talking about the value of this difference quotient and how to find it. All right, so let's do some examples. All right, so we're going to be finding the secant line and finding its slope. That's our direction. So first off, we're going to graph the secant line. All right, so it says on the interval closed from 1 to 4. That means I'm looking for everything in between 1 and 4. That's what I'm looking at. So that would be from here to here. So that's what the interval is all about. So that's the first step. We're going to find that interval. And again, we find that interval by finding 1 and 4 on the x-axis and finding their corresponding points. Now, to draw the secant line, what we need to do is draw a line that connects those 2 points. That's the secant line. That'll be step 1 in your directions today. Draw a secant line for the given interval. All right, now we want to find the slope of that secant line. So that's just simply a rise over run count. So let's go ahead and count from this one. Let's count down. It goes from 5 down to 2. So we're talking about a rise and run of down 3. And then a run goes from 1 over to 4, so we're talking about a run of 3. Reduce that down to -1. Again, those are your directions today. Draw a secant line on a given interval, and then find the slope of that secant line. All right, another ugly looking graph, but that's okay. So first off, let's find this interval. Closed interval from -5 to -2. Again, we always list it from left to right. So go to the left to -5. All right, that's here. And then we're going to scroll up to where the graph crosses that line. And then -2. Yep, there's already a dot there, but that's okay. All right, now a secant line is a line that goes directly between those 2 dots. And it'll tell us the average slope in that zone. All right, now to find the average slope between those 2 dots, we're going to count our rise and run since we have a picture to look at. If we just had information, we would be doing something different. So we're going to count our rise and run. So that's down, at least counting by 1, so down 1, 2, 3, so down 3, and then right 1, 2, 3. Oh, it's the same as the last example, but that's fine. Got a slope again of -1. Is the average slope between those 2 dots on the closed interval, -5 to -2. So again, practicing a couple of things we've already used a little bit, how to find slope, how to use intervals. All right, so that is it for today. Again, we're going to get a little bit more in depth with this the next few days. Good luck.